Hello my friend, and welcome to the next BMS chapter. So in this chapter we are going to learn how to control chiller and monitor it in BMS control application. The level of this course is basic. By the way, my name is Amir. I'm a KNX tutor and also BMS expert, and I hope to have a great training with each other. So let's start. So this is a schematic figure of the simple chiller. Okay, so you can see we place the different sensors and actuators to control and monitor this chiller. Also, we have electrical panel part, some brain of the chiller to control and monitor it individually at the place of this. So we start to monitor the temperature in input and output of evaporator. So we use the immersion temperature sensors. As a BMS side, we need analog input to read the temperature of input and analog input to read the temperature of output. Of course, it depends on the type of the sensors. So two analog input we needed for evaporator. About the condenser, we need to read the temperature input and output of the condenser. So we need another two analog inputs as a BMS side, and we need differential pressure transmitter because we want to aware about sediments in the condenser, so we use a differential pressure transmitter here. So we need another analog input. Also, the input of the condenser and output of the evaporator, we need the flow switch. So why? So in condenser, we should make sure that the water is coming in from the cooling tower, and about the evaporator to avoid any ice situation. So we use the flow switch, because if the ice is happening, the chiller should be switched off. So we need flow switch over there also. To read the flow switch, to monitor the flow switch, we need the digital input because it provides us only contact. So we need one digital input for flow switch at input of the condenser, and one flow switch, we need one digital input at the output of the evaporator. So apart from the sensors located at the chiller, we need one digital input to read about the trip status. So if there is some trip in the electrical panel, we want to monitor the latest situation. The next one is to monitor the reset status of the electrical panel. So if so this is the read status. So we are going to read the latest status of the control panel or electrical panel of the chiller. We want to read it, so we use the digital input to read the latest status of the electrical panel. So the next one is the reset command. So we want to send the command from the BMS to reset the system. So we use the digital output from the BMS side to reset the system, and also we have the digital output to switch on and off the system completely. So we need the digital output to send the control command. And finally, we need the analog output from the BMS side to send the set point to the electrical panel, possibly. Of course, each case by case should be studied the project, but this is some simple approach to control and monitor the chiller. So let's continue with what type of sensor we have in the BMS. So this type of sensor we are going to use to control and monitor the chiller, as we already talked about it. So this is an immersion temperature sensors. You can see on the left picture the direction of the installation. We should follow the rules. And also about the wiring at right side, it depends on the sensors. If the sensor is resistive type, so we should follow it, or this is the active type, so choose between 4 to 20 milliamp type or 0 to 10 volt DC signal type. So it depends, the wiring, it depends whether it's resistive or active. Always we should follow the data sheet for that. Yeah, the installation and wiring. So the next sensor we talk about it is differential pressure sensor or transmitter. So you can see about the type of the installation at the right hand side and about the wiring at the left hand side. So this wiring is it's provide us the output 0 to 10 volts DC. So always these type of transmitter provide us 4 to 20 milliamp or 0 to 10 volt DC. So they are the active type, so we need the analog input to read it. About the flow switch, you can see in the picture, so also for the flow switch we should follow the rules of installation according to the type of the sensor we are going to buy and install it in the project. And also about the wiring, it provides us most of the time the dry contact, so we should read the dry contact by one digital input. So when we purchase and want to install it, we can follow these rules. First of all, we need the main controller with input and output. You can see in the picture on the right hand side, and also we need the temperature sensor for input and output of evaporator, and also we need the flow switch at the output of the evaporator and at the input of the condenser, and also we need the temperature sensors for input and output of the condenser, and the differential pressure transmitter between input and output of the condenser. Also we have the input and output communication between the main controller input output card and electrical panel. So you can see at the left hand side we have, for this type of simple chiller, we have the 5 analog input, 4 digital input, 1 analog output, 2 digital output. So then we are going to choose the right controller plus input and output. For example, in the picture you can see the compact controller based on BACnet. So according to the table we are going to choose the right product for that to provide us the adequate or enough analog input, digital input, analog output and digital output. Also from the Koenig side we can go with the single type to choose, for example, from RMU to choose the right controller and input output card next to it. So here you can see I provide you some alternative solutions. Sometimes when you as a BMS person go to the site, and or you are going to study the documents of the projects, you can see the chiller provides you the Modbus communication or BACnet communication. It makes our life very easy in this case, because most of the time there is no need to install the separate controller or sensors and so on. So you can communicate from the monitoring level in BMS to the chiller directly, or from the control level to the chiller directly. So for Modbus, you should have the register table of the chiller and related information to communicate between the BMS side and Modbus. And also for BACnet, you should have the register table and a list of the object of the BACnet. Then you can communicate with the chiller. So this is alternative solutions if your chiller in the site provides you the communication based on these protocols, because in this case already all the sensors and so on are located in the chiller itself. Okay, so the principle of the chiller. So it is important as a control engineer you understand the principle of the different type of the chiller to have the better control idea to how to design the control concept, controller, how to monitor and how to treat it and during the operation. So first of all, you should know about the fundamental. So evaporation process, superheating, melting and condensation. You should know about it, what they are mean. So we most of the time we have two type of chiller, absorption chiller and compression chiller. So in absorptions, what's happening? So if I want to tell you very brief, we can say in the absorber, the lithium bromide absorbs the water refrigerant, creating the solution of water and lithium bromide. This refrigerant, usually water, can change phase easily between liquid and vapor and circulate throughout the system. So this type of chillers is based on the water and lithium bromide and the change of the phase between for water as a refrigerant between the vapor and liquid, liquid, vapor. Yeah, that's it. So these type of chillers, instead of the power, they need heat. So this heat coming from the natural gas. So heat from natural gas combustion or waste heat source and so on. So you can use the direct heat from the burning of the natural gas, or the hot water, or the hot steam and similars. Okay, so if you want to understand the absorption chillers, there's a long story how it works. I'll just provide you some text. You can see there are many aspects for this type of chiller. So important things is for the absorption chiller is in control, and in BMS we are not interfere the control loop of the absorption chiller at all. We just monitor it. Okay, we let the systems work independently, just we monitor it. And of course we can switch on and off and the systems, but there are some limitations in absorption chiller, like the possibility of crystallize of the system, so we should take care about it. About the compression type of the refrigeration systems, in the picture you can see most of the times it consists of 4 parts. Evaporator, so evaporators most of the time is placed in the mechanical room in the chiller itself. So compression chillers coming with evaporator inside. This is the place that the water supply, cold water of the buildings coming from the evaporator. Then number 2 is compressor. So compressor also is a part of the chiller, inside of the chiller. The third part is condenser. Condenser is the place that we take out the heat from the refrigerants coming from the compressor. And also the number 4 is expansion valve. So it consists of 4 parts in the compression refrigeration process. You can see in the picture that in the evaporator, the water coming from the building is 12 centigrade, for example, and the water is 6 centigrade is going to insert into the building. So the evaporator is the black part in the chiller figure you can see in the picture. And also in the picture you can see the water from the cooling tower is going to the cooling tower 60 centigrade, coming 55. So this is going to be insert in and output of the condenser to make the refrigerant gas a bit cooler from the output of the condenser. So the different type of the evaporator you can see in the picture, we have the different type of the evaporator. We have the different type of the compressor. We have a different technology for the compressor. The idea is to have the less noise, more efficient, and so on. For the condenser part, you can see in the picture the different type, like water cool or air cool condenser. And for the expansion valve, you can see in the picture how it defines. So in vice versa, I mean in opposite of the the chiller type, we have the heat pump. Also heat pump consists of 4 parts, like condenser, evaporator, and expansion valve, and so on. But the direction of the refrigerant gas is different. So in heat pump, we are going to use the heat outside of the building, that is for free in the nature, and we are going to use the very less electricity to make the inside of the building hot. So this is also the part that is going to be controlled and monitored in the BMS systems. Thank you very much for watching this session. These sessions at the beginning we cover how to control and monitor the simple chiller, and also in the second part we mentioned that we have different type of the chiller and process. For you can read it in much more detail because it's a mechanical part to study. Thank you very much. Have a nice day. If you have any questions, please let me know by email.